Welcome to our video tutorials for our PC tool, openSYDE. In this video, we would like to introduce you to the topic NVM data pools. If you are not yet familiar with the basics of openSYDE, we recommend you watch the video Basic Introduction to openSYDE from this series. Controllers are provided with certain parameters that are loaded during startup and provide for a certain basic configuration. Such parameters are usually stored in non-volatile memories, or NVMs for short. The memory media on the controllers for this purpose are, for example, the EEPROMs. openSYDE offers the possibility to create NVM data pools for such parameters. This makes it easy to create entire lists of parameters with a few mouse clicks and use them in application programming by generating code. Via special widgets, you can also read out and change the parameters during operation of the controller via openSYDE, and thus adapt the controller to special environmental conditions. With additional dashboards, openSYDE can communicate with the controller via all created data pools, and thus the effects of the changed NVM parameters can be checked. You can export the configured values in the NVM data pools in a special format. You can then make this exported data available again in the update packages for openSYDE and write it to the controller together with the hex files for the application. This works with an openSYDE project, a service project, or with SYDES-UP.exe, the console application for updating your system. In this video tutorial, we show you how to export the NVM data pools correctly, how to provide them in update and service update packages, and how to write the parameters directly into the EEPROM of a controller. Our experimental setup consists of a controller ESX3CS from a starter kit, which is powered via the breakout box. During the video, we will demonstrate a measurement, and for this we can connect a voltage output to a measurement input on the breakout board. Ethernet is used for communication between the controller and the openSYDE client PC. All necessary steps, like for example the device configuration, have already been executed for this video. The example application from the target support package of the ESX3CS is running on the controller. First, you should set up a controller in the lab the way you want it to work in your system. The configuration of the parameters can then serve as a template for all of the controllers that you wish to operate with the same parameters. For demonstration purposes, we use the sample project of the ESX3CS controller that STW provides with the target support package. We have created a directory on this PC where we have installed the target support package and navigate the openSYDE sample project. The file extension SYDE is linked to openSYDE, and we start the sample project by double-clicking. We see a topology with two controllers. We select one from which we now want to derive the template for the other controllers. The parameters for the EEPROM are already created in this example and are also used by the sample application. We can find them under data pools. The EEPROM is a non-volatile memory. The associated data pool is therefore an NVM data pool. This data pool is called calibration and contains a list of two data elements. In this case, parameters that describe an offset for measurement inputs. Via generate files, openSYDE produces C code for direct use of the data elements in the application. In the sample application we use here, the EEPROM content is read and written to the data pool. In the code of the application, you could see that the measured values of the inputs IDA35V1 and IACV1 are increased by the offset specified here, and these corrected values are written into the data pool for the measured values. To do this, let's take a closer look at the I/O dashboard. For the displays, we can access data elements from the data pools, for example, from the diag data pool inputs from the elements in the list analog. In this widget, the value of the data element IACV1 in the list analog from the diag data pool input is used for display. For the display of the offset, the already established data element from the list of the NVM data pool calibration is used. We have now connected this voltage supply output to this measurement input on the controller for demonstration purposes. When we go online with the dashboard, we can measure the actual voltage set with the input. Although we set 12 volts as the output voltage, we measure a little less. Using the logic describer, I can adjust the displayed reading by changing the offset. For this purpose, another dashboard, calibration data, is created in our example, which contains a so-called parametrization widget. We delete this and create it again to demonstrate the process. We drag the widget from the toolbox to the dashboard and assign the list of data elements in the NVM data pool. Now, when we go online from this dashboard, we can read out the current parameters of the EEPROM. We can also change these parameters and write them back into the EEPROM. To adjust the measured value for the voltage, which was a bit too low before, we select 10 millivolts and the action write. In openSYDE, this write process for the EEPROM has been implemented with a parametrization widget in accordance with various safety standards, which we describe in more detail in the certificate. This ensures the secure writing of the parameters. First, the confirmation by the user is requested that the parameters should be written, and then the confirmation that this already written and read back data is really valid. These manual steps prevent unchecked overwriting of EEPROM values. The application does not work directly with the values from the EEPROM, but always with the RAM copy of this data. openSYDE indicates in the dialog that the RAM copy was not updated by the write operation in the EEPROM. We can prove this by initially not setting the trigger application checkmark, which would cause the EEPROM values to be read by the application. First, we recognize that the offset value in the EEPROM was changed to 10 millivolts by the write operation. We can also confirm this by reading the value again. We switch to the I/O dashboard. We have remained online unchanged and recognize here that the offset value is still set to 0. Hence, the data element of the data pool has not yet been updated in the RAM. We therefore go back to the parametrization widget and change the value again to 14 millivolts. Write it to the EEPROM, confirm the validity, and this time request the application to copy this value to the RAM as well and continue working with it. Let's take a look at how this action affects our readings. To do this, let's go back to the I/O dashboard. The changed offset is displayed and also the change measurement result, which has been corrected upwards by 14 millivolts via the offset, so that the set voltage value and the measurement result now match each other. As we see with the parametrization widget, you can conveniently change the EEPROM parameters and check the effect of the changes when you update the RAM copy and let the application work with these values. Now we want to save and export these change parameters to be able to use them for other controllers as well. There are two ways to save the set parameters. These are offered to us again by the parameterization widget. With the save option, you can save the parameters in a file in SYDE_PS format. Since this is possible offline, the file contains the values currently known in the openSYDE project. The file can be created for the whole project, a node, a data pool, or for a list in the data pool. Such files can be used to load parameters into the parameterization widget and are thus limited to the PC tool. The controller would only be changed when we go back online and write these values into the EEPROM via the action write. To save the current values that are actually used in the controller, openSYDE offers the record option. This can only be used in online mode. We therefore go online again with the dashboard. This function creates files in the format SYDE_PSI, the so-called parameter set image. We create this file in the directory of our choice. To do this, we first read the parameters from the EEPROM and confirm that all the required parameter lists are included. For demonstration purposes, we now change the set parameter for the offset back to 0. Confirm this and trigger the application to accept the value again. By rereading the EEPROM, we make sure that this has actually been done. Also, in the dashboard for the IOs, we can see that the value for the offset is actually back to 0 and the measurement result is below 12 volts again. We will now use the parameter set image we just saved to write the EEPROM parameters while flashing the controller. To do this, we switch to the update function. The update package consists only of the hex file, which is stored by default in the data block. In the section Other Files, we can now add the EEPROM parameters. For this, we use the function Add New Files in the context menu. SYDE_PSI is one of the permitted file formats. We navigate to the directory where the parameter set image is stored and selected. After clicking on Enter Update Mode, it is shown that the controller has to be updated. The hex file is already on the controller, but not yet the EEPROM parameters. By clicking on Update System, these parameters are now written into the EEPROM. We leave the update mode and in doing so, reset the controller. Now we can make sure that the parameters have been written correctly into the EEPROM. For this, we go online again with the dashboards. Already on the IO dashboard, we can see that the offset for input IACV1 has been reset. In the calibration dashboard, we can also read out the values and see that they were correctly transferred into the EEPROM. This writing of the parameter set images during the update not only works with the openSYDE application, but would also be possible via SYDESUP, the console application for the update process. With the Create Service Update package function, the parameter set image is packed along with the hex file. Thus, we create this service update package consisting of the hex file and the parameter set image file. In the Windows command prompt, we now run sides up with the package we just created and see in the log that in addition to flashing the hex file, the NVM values have also been written to the EEPROM. We hope that we have brought you a little closer to the NVM data pools. We summarize. NVM data pools are used to manage the parameters that are written to the EEPROM of the controller. Editing is done via parameterization widgets. Parameters tested and stored on a controller can be exported as parameter set images. Parameter set images can be written to the EEPROM during flashing of a controller, either via openSYDE or via the console command sides up. In this series of openSYDE videos, other videos appear on this channel that deal with the details of single features. We wish you every success using openSYDE.